steel cables used the construction of suspension bridges has whatever it is. As a statistician, I'm just looking for, this is the data for new cable, this is original data, this is given in kilogram times 10 to the power 3, so this is in 1,000, this is in 1,000, right? Okay, and what is the question here? Yeah, decided that 1% level of significance, this is my alpha, right? It is 1%. Any statistical testing procedure to adopt to distinguish between the cables on the basis of results given, should the manufacturer replace the old one by the new one? So I'm just comparing this, the mean for this to 1. This is the stronger. He's saying, and the cables produced being stronger in the sense that they will accept greater tension, right? So this is a cable given the measurement like this and the tension failure, and this is it. So if I compare the mean, I can say which one is better than the other, right? Okay, but I'm going to use t-test because what? Yes, the sample size in each sample here is less than 30. Also, I'm not given the standard deviation of the population. This is why I'm using t-test to compare the means, right? For the two sample, for the two populations. Also, yes, t-test to compare two population samples. Okay. There is a t-test for equal variance and unequal variance. Do I know the information like the previous example? As he said here, he assumed they having the same, the population standard deviation are not the same. So I know I'll go for t-test to compare the two means population, to the population means for t-test unequal variance. And also in this question, right? Also in this question, he given me they have equal variance. So to compare the means, I will go for two t-test for an equal variance. So when it is mentioned in the question, that's okay, but it is not mentioned over here. So what I supposed to do? Yes, I'm going to use f-test, and the result of f-test telling me this information, they are equal variance or unequal variance, the two populations, right? Okay. So first, I have to know the two population have the same, have equal variance or unequal variance. So what I'm going to do, I'm going to do f-test. Okay, so first use f-test to compare the variance, the two population variance. I just need for f-test the null hypothesis. For the f-test, the two variants are equal. Sorry, there is S over here. Are equal. This is the null hypothesis. The alternative is the same, but I make the opposite statement. So the alternative, I call it HA. Okay. And instead of equal, I'm saying unequal. Because I said unequal, so it is two-tail test. Two-tail f-test. Okay. Now I'll go for data analysis. I go for F. What is F? F-test. Yes, for two sample. Okay. I go for shading the first sample. Next, I shading the second one. I have a label because I have name in the first cells. Okay. It is not 5%. In my question here, he's telling me it is what? 1%. So be careful to know what is your alpha here. So it is 1%. I need the result just down here. I put the mouse inside this one and any empty space here enough for the result. I just click OK. I get the result. I'm just shading the p-value just to have a very quick decision, right? It is one tail or two tail? Yes. F test is only one tail, right? So I will take it only the right one because the F is the area to the right, to the critical value, not to the left, right? Okay. Good. So I have only F stat here. Okay, and F critical is here. F stat value, is it bigger or less? It is less. Less than what? Less than the critical value. So what are we going to say here? Yes. I just make it bigger and also make it red. So because the F stat before the critical value, so we accept yes, the null hypothesis. Okay. What is the null hypothesis? Yes, the null hypothesis, they are equal variance, okay? So when you're saying we accept this one, you have to know what this one is. Okay, fine. So also, if you're going to compare this one using the p-value, this is bigger than, this is the p-value. The p-value is bigger than the alpha or the level of significance. Alpha is what? Yes, it is 1%, which is exactly 0.01. Okay, this is why I'm saying this is bigger. When the p value is bigger, you accept the null hypothesis the same, right? So even using the p value or comparing the stat value with the p value, you should have the same decision, right? So the two variants are equal. So to compare the mean now, up to this one, yes, here, I'm just saying. So to compare the mean, compare the two population means, use what? Yes, we use t-test, two sample t-test, two sample t-test for equal variance. Yes, this is the result of equal variance. This is the result of my F test because I don't have the information like the previous questions. Okay, so I'm just copy this one, Control X, just have it here, Control V. Okay, just to not to be far away. Okay, now let's do the t-test for equal variance. I'll go for data analysis. I am going for t-test equal variance up to the result of f-test because I don't have the information saying the two populations have the same variance or different, right? Okay, so I'll go for equal variance. Okay, now I'm just shading the first sample. And then in the next window, the second sample, I null hypothesis, they are the same, so the difference is 0. I have a label because I have a name in each column, the first cell. No, alpha is not 5% in this time. Alpha is 1%. I would like to have my result anyway, but you should have empty space, right? Don't make it overwrite, okay? So I'll take it up here, okay? So this is my result for comparing the means. So I cannot compare the means if I don't have the information, the two populations having the same equal variance or different equal variance or unequal variance, right? If I don't have this information, I have to do the F test. Now, what is this one? Yes, the null hypothesis in this t-test is, yes, I'm just copy this one, and instead of variance, I'm saying equal means, right? So using the computer is saving time, right? Control V. So this one, instead of variance, the two means are equal, right? So instead of the two variance, you say two means. Okay. And the alternative hypothesis, he said stronger in the question here. You would like to say, I have a word here saying a new cable comparison to the old one cable. Okay. You would like being stronger. Okay. So the new one should be stronger, right? So the mean HA, the mean of new cable should be bigger than the mean of the old one or of the original one. Okay, I got this one, I catch it from the question because he said the mean of, he would wish to have a stronger cable, so the new one should be stronger. So up to this one, it is what? Yes, T is two tail tests, right? Two, no, sorry, it is one tail test. One tail test, exactly the right tail. Okay, so when I'm going to shade, I'm going to shade one tail for t-stat. I can comparing using t-stat, okay, with t-critical, and I comparing this one, the t-stat. T-stat, is it bigger or less? It is less, right? Less than a t-critical. It is less. It means it is not in the rejection area, right? Okay, so you accept. Oh, we accept null hypothesis. Null hypothesis, the two means are equal. Okay, it means in summary, there is no significant difference in the what? I just get the word here, in the strength and the tension, right? Or in the strength, I can say, okay, and the strength, of the original cable and the new one. Fine, fine. So I answered the question. Also, I can compare this one using the p-value, if you would like to say. So I can choose different color. Okay. So this one, I compare it with what? The p-value, I compare it with what? Guys, Yes, with the alpha,
With
right?
alpha.
So this is bigger than alpha, which is 0.01. So you have the same decision, right? You have the same decision. This one or that one, it's up to you. Okay, so that's it.